All right, Algebra 2. Welcome to Unit 2. Unit 2 and Unit 3 are on polynomials. And in Unit 2, we're going to specifically look at quadratics. So remember, quadratic is like an x squared, has a degree 2. And so before we actually get into things that we're going to be doing with quadratics, like solving and graphing, we're going to go ahead and look at what are called complex numbers. And before we do complex numbers, we're going to kind of review radicals again, because radicals come up a little bit in this unit. All right, so square root of 49, remember, you can plug it in the calculator. You're looking for two numbers that are exactly the same that equals the number under the radical. So 49, again, is 7 times 7. And so because you have a pair of 7s, this simplifies down to just 7. Again, you should know square root of 49 simplifies to 7. All right, number 2, square root of 60. Now, square root of 60 is not a perfect square, so we do want to break that down. All right, you can break it down into any two numbers that multiply to 60. It doesn't matter how you start. So here I'll just start with 6 and 10. 6 I can still break down to 2 times 3, and then 10 I can break down to 2 times 5. And that's as far as you can break down. Now you're looking for a pair of the same number. So here we have a pair of 2's. So a 2 is going to come out, and then the 3 and the 5 are not paired up, and so we just multiply those back together. So the 2's on the outside, 15 will be on the inside, and we have this plus or minus symbol in front. And occasionally we'll have a number or a plus or minus or just a negative. And so we're going to keep that symbol. Okay, and so the 2's on the outside, we're going to keep that plus or minus in front. So it's plus or minus 2, and then radical 3 times 5, so that's going to be 15. So plus or minus 2, radical 15. So we want to put that plus or minus in front of the 2, not in between the 2 and the radical. Okay, number 3. Same thing, square root of 32, we know that's not perfect, so we can break it down. Here we could use 4 and 8, 2 and 16. Okay, 4 I can break down, 2 and 2, so there's a pair. And then 8 I can break down 4 and 2, and then 2 and 2 again. So there's another pair. So I have a pair of 2's and another pair of 2's. So that means 2 times 2 is 4 on the outside, and then this 2 stays on the inside. Now, because there's a 5 already out there, we're going to multiply the 4 with the 5, so that's 20, and then radical 2. All right, number 4, here we have a division of radicals. I can't simplify 7 and 3, and so I can't leave a radical on the bottom, so here I'll just multiply top and bottom by radical 3. Multiply across, I get radical 21, all over radical 9. Radical 9 and simplify down to 3, exactly 3. So root 21 over 3. And you can't simplify the 21 and 3 because the 21's on the inside of the radical, where the 3 is not under a radical. All right, multiplying radicals. Again, this is review. With multiplication, we can multiply outside with outside, inside with inside. You could simplify radicals first and then multiply. It's up to you. Here, so I'll multiply the outsides together, so 4 times 2 is 8. I'll multiply the insides together, 5 times 7 is 35. All right, so I have 8 radical 35. I want to see, can I simplify radical 35? I can break it down to 7 and 5. I don't have a pair, so that means root 35 does not simplify, and so my answer is root 35. Number 6, same thing. Negative 2 times 3 is negative 6. 5 times 8 is 40. Again, I've got to see if I can simplify. 40, I could go 4 and 10. 4 is 2 and 2, so there's a pair. 10 is 2 times 5, and you don't have another pair, so that 2 times 5 will get multiplied back together. So the 2's coming out. I have a negative 6 already out there, so those get multiplied together. So 2 times negative 6 is negative 12, and then I have 2 times 5, and that's 10 left inside. All right, so again, that's all review of radicals. So now what we're going to do is look at a new number system called the complex numbers. So the complex numbers are made up of two number systems. One is the real numbers, which we talked about at the it's like the first day of this class. Real numbers are any numbers that you can plot on a number line. So those are all the natural numbers, the whole numbers, the integers, the rational numbers, irrational numbers. That whole set, all those numbers make up the real numbers. And then we have this new set of numbers called the imaginary numbers. And so we'll see what an imaginary number is. And if we take the real numbers and the imaginary numbers and put them together, we get a whole new complex number system called the complex numbers. Okay, so what is an imaginary number? So an imaginary number is going to be a number where there's a negative number under the square root. Okay, so it has to be a square root, not a cube root. So what we can do is take that this example square root of negative a, and that really says the square root of negative 1 times a. So we can rewrite this as negative 1 times a. Now what I can do is I can split this up into the square root of negative 1 times the square root of positive a. Now the square root of negative 1, this is a special number, and this is called I. Okay, so we're going to replace the square root of negative 1 with I. Okay, the I is for imaginary, and then times the square root of positive. Right, and so that's how we're going to deal with negative numbers under radicals, the square roots. We're going to pull that negative out, and it turns to an I on the outside, and now the number on the inside turns positive. All right, so again, I is equal to the square root of negative 1. If I were to take this equation, I equals the square root of negative 1, and if I square both sides, okay, just so you can see, if I square both sides, then I get I squared equals, well, the square root of negative 1 squared actually simplifies down to negative 1. And that is because of the concept of square rooting a square, or squaring a square root. If we were to take the square root of 3 squared, for example, this is equal to 3, because the square root of 3 times the square root of 3 is equal to the square root of 9, and square root of 9 simplifies to 3. So when we're squaring a square root, we can basically cancel these out, and because they're actually called inverses. Okay, we talked about inverses in Unit 1. They're inverses of each other, and so they undo each other. And so then you're just left with a number under the radical. Okay, so anytime we see an I squared, we're going to change it to negative 1. That's going to be a concept that will come up later on in this lesson. All right, so when we want to simplify an imaginary number, the first step is always pull the negative out. Okay, I'm going to pull that negative 1 out. So the negative here on the square root of negative 6, the negative comes out, and it doesn't become a negative, it becomes an I on the outside, and then radical positive 6. All right, so the square root of negative 6 is I radical 6. B, the square root of negative 9. Again, we'll pull that negative out. And then we can simplify the radical. Square root of 9 is just 3. So I times 3, we're going to rewrite it so the number comes first, because it just looks nicer when the variable comes second and the number comes first. So 3I is the square root of negative 9. All right. So let's go ahead and simplify each of these radicals. Okay, again, first step, anytime you have a negative under the radical, pull that negative out. Okay, so here we have I root positive 125. Now we want to simplify our radicals if we can. So here I could break this down into 25 times 5. And then 25 is 5 times 5. So there's a pair. So that 5 comes out. It gets multiplied to the I. And I get 5I radical 5. Okay, so this 5 is this 5 right here. All right, number 2. Same thing. I'm going to pull the negative out. I root 12. Simplify radical 12, 4 times 3. 4 is 2 times 2, so here's my pair. So 2I radical 3. Number 3, pull the negative out. Okay, so there's a 2 already out there, so I'm going to multiply 2 and I together. So it's 2I radical 10. I'm going to try to simplify radical 10. I can break it down to 2 times 5. And I don't have a pair, so this is the final answer, 2i root 10. Okay, multiplication. Again, your first step has to be to pull the negatives out. Okay, so this negative comes out, and this negative will come out. So negative 3i root positive 10 times I root positive 2. Now we can multiply outside with outside and inside with inside. So negative 3i times I is actually negative 3i squared, because I times I is I squared, just like x times x is x squared. And then square root of 10 times 2 is 20. All right, now I've got to simplify this. Now, anytime there's an I squared in the problem, we're going to go back and change it because of this rule right here. Anytime we see I squared, that's negative 1. So we have negative 3 times negative 1 root 20. Negative 3 times negative 1 is positive 3. All right, so now we have 3 root 20. Now I can simplify 20. Okay, I can break it down. That's 4 times 5, 2 times 2, so there's a pair of 2's. So the 2 comes out. There's a 3 already out there, so that's 6. And then the 5 stays inside. All right, so let me rewrite the answer here. So that's going to be 6 radical 5. All right, number 5. Again, let's pull those negatives out. So 2i root 15 times I root 3. Multiply outside with outside, inside with inside. So 2i times I is 2i squared. Square root of 15 times square root of 3 is square root of 45. I squared is negative 1 times 2 is negative 2 root 45. Now I got to try to simplify radical 45. I can break it up into 9 times 5 and then 3 times 3. So there's a pair. 3 comes out. There's a negative 2 already out there, so that's negative 6. And then radical 5. All right, number 6. So square root of negative 10 squared. So you'll see there is a shortcut on this. The square and the square root cancel each other out. So that's going to simplify to negative 10. But let's say you didn't know that. We could rewrite this as square root of negative 10 times square root of negative 10. Remember, something squared means write it twice. Then we can pull the negatives out. So we get I root 10 times I root 10. Then we multiply the outsides together and the insides together. So that's I squared root 100. I squared is negative 1. Square root of 100 is 10. If you multiply these together, you get negative 10. So that's going to be the same thing as if you canceled the square with the square root, you get negative 10. All right, so a complex number, again, is written up. It's made up of real numbers and imaginary numbers. And so this a plus bi is the standard form for any complex number. The a part is any real number. So any number that you can put on a number line, that's an a, the a value. The bi is the imaginary part, so that has an I in it. And if you put those two together with a plus or a minus, then that's called a complex number. All right, we can graph complex numbers. It's similar to how we graph a point on the xy axis, but here in a complex number, we don't have an x-axis and a y-axis. We have what's called the real axis and the imaginary axis. So the real axis is for the real number, and the imaginary axis is for the imaginary number. And where they would intersect is the point that you would graph. So again, if we're graphing these, kind of think of them as ordered pairs. So if we wanted to graph the complex number 3 minus 4i, you can kind of treat it like 3 comma negative 4i. Okay, so you would go to positive 3 and then go to negative 4i, so that means you go down 1, 2, 3, 4, negative 4i, and where they intersect each other is the complex number. All right, so that point right there is 3 minus 4i, and we'll just label it with the letter A, so we don't have to write the whole 3 minus 4i. Okay, so that's how you plot a complex number. We can do B, -2 plus 3i. Okay, so we'll go left 2 on the real axis number line, and then go up 3i to go on the imaginary axis. So we can go left 2, up 3. 1, 2, 3. That's us right here. And that's the complex number, -2 plus 3i. So we'll just label it B. All right, and then let's do this last one, -I. So this is the same as 0 plus, 0 minus I. All right, so 0 is the real number, and the -I is the imaginary number. So we would go, we don't go left or right any, we'll just go down to -I or -1i. Okay, and so this point right here is a complex number, -I, and so we'll just give it letter C. All right, adding, subtracting, and multiplying complex numbers, same concept as when we did polynomials and when we did functions. Right? So with adding, we could just drop the parentheses and combine like terms. Okay, so 2 minus 3i plus 7 plus 4i. All right, so we can add the like terms together. 2 plus 7 is 9. Add the imaginary parts together. Okay, so those are the i's. -3i plus 4i is +1i. And this is as far as you can go. So this is called standard form. Again, has a real number and imaginary. All right, number 9, 6 minus 5i minus 3 minus I. So just like with polynomials and functions, when there's a subtraction, when we're subtracting, we want to distribute that negative in first, and then drop the parentheses, and then combine like terms. Right. So we're going to add the real numbers together. So 6 minus 3 is 3. -5i plus I is -4i. All right, multiplying complex numbers, we're going to use double distributing. What happens in multiplication, though, we'll get an I squared in the answer, and so we'll have to change I squared to -1. All right, so let's go ahead and double distribute first. So -7 gets multiplied over. Again, if you want to use the box method, if that's easier for you, then use the box method. -7 times -4 is 28. -7 plus I, or times positive I, is -7i. All right, now we'll distribute -I. -I times -4 is +4i. And then -I times positive I is -I squared. All right, we can combine like terms in the middle. Okay, and then this I squared here, remember, changes to -1. But there's already a negative in front. Okay, so this really says -1, which will change to a +1. All right, so right now we have 28. Combine like terms in the middle, that's -3i. And then minus and times a -1 is going to change it to +1. So -I squared changes to +1. Now I can add 28 and 1 together, so it's 29, and then -3i. All right, number 11, 7 plus 6i, all squared. All right, so this works just like when we're squaring a function, a binomial, you have to write it twice. You can't just bring the exponent in. And then we'll double distribute on this. So 7 times 7, 49. 7 times 6i is +42i. 6i times 7 is +42i again. And then 6i times 6i is +36i squared. Right, we're going to combine like terms. We're going to change the +36i squared. Remember, I squared is -1. Okay, we're going to take that -1 and multiply it to 36. So 49, combine like terms, 84i minus 36. Now we can combine 49 and -36 together. So we're going to subtract those, that's 13 plus 84i. All right, and then number 12, let's do one more multiplication problem. Okay, again, we're just double distributing this. So negative 3 times negative 3 is positive 9. Negative 3 times 4i is minus 12i. Negative 4i times negative 3, again, is this is going to be a positive 12i. And then negative 4 times negative 4i times positive 4i is negative 16i squared. Combining like terms, negative 12i and 12i, those are going to cancel. Okay, we have minus 16i squared, which is really going to change to plus 16, because I squared is negative 1 times negative 16 changes to positive 16. Now I can add 9 and 16 together, and I get 25. Okay, so all the i's canceled out on this one. All right, so that's how you add, subtract, and multiply complex numbers. All right, and then now we're going to be looking at division. So with division, we use conjugates. Okay, so in unit 0 with the radicals and division of radicals, we use conjugates, and we're going to use that same concept on division with complex numbers. So the conjugate of any imaginary number, again, all it does is changes the sign of the imaginary part. So if we have a complex number a plus bi, its conjugate is a minus bi. A minus bi, its conjugate is a plus bi. All right, so let's practice writing the conjugates of each of these again. So number 13, 4 minus 2i, its conjugate is 4 plus 2i. Number 14, the conjugate is negative 3 minus 5i. And number 15, the conjugate of negative 4i is positive 4i. All right, so with complex numbers, we're trying to get rid of the I in the denominator, and to do that, we have to use conjugates to do that. Again, this is similar to the radicals, how we got rid of radicals in the denominator. We had to multiply by the top and bottom by the conjugate. All right, so 16, we're looking at the denominator, 2 minus 4i, and so we're going to multiply top and bottom by the conjugate, which would be 2 plus 4i. Again, treat these as like binomials because you're distributing. So we're going to double distribute this out. All right, so taking 3i, we can distribute 3i in. 3i times 2 is 6i. 3i times 4i is plus 12i squared. We'll double distribute on the bottom. Okay, so 2 times 2 is 4. 2 times 4i is plus 8i. Negative 4i times 2 is minus 8i. And negative 4i times positive 4i is minus 16i squared. So if you do these conjugates correctly, on the bottom, what happens is these middle terms are always going to end up canceling out. So really all you have to do is multiply the first terms together and the last terms together for the bottom part. Okay, so let's continue to simplify this. Remember, anytime you see an I squared, it's going to change it to negative 1. So on top, we have 6i plus, now I squared is negative 1 times 12 is minus 12. And if you want to write that as 6i minus 12, that's the same thing as 6i plus negative 12. On the bottom, okay, again, we have another I squared. That changes, I squared changes to negative 1 times negative 16 changes to plus 16. I can add 16 and 4 together. That's going to give me 20. All right, I have to write this in standard form, meaning the imaginary part comes second. So on top, I have the imaginary part coming first right now. So I'm going to just switch all this around. So it's negative 12 plus 6i all over 20. Now, once you get to this step, if you have 3 numbers, so here's 1, 2, 3. If there's a number that divides into all of them, you have to divide them all by that number, just like we did with the radicals. So we can divide them all by 2 to simplify this fraction. All right, so if I divide by 2, I'm going to get negative 6 plus 3i all over 10. Okay, now that's simplified all the way. All right, let's do 17. 2 over 3i. So we're going to multiply top and bottom by the conjugate, which is negative 3i. Multiplying across, 2 times negative 3i is negative 6i. Multiplying the bottoms, 3i times negative 3i is minus 9i squared. Okay. I squared on the bottom is negative 1. Okay, again, that's negative 1 times negative 9 is positive 9. And then negative 6i on top. All right, here, I just have a single term on top and bottom, and I can divide them all by 3. So then I get negative 2i over 3. All right, and let's do one more, 18. All right, so we're going to multiply by the conjugate, which is 1 minus 3i. We can do that to the top also. And we're going to put all this in parentheses, and we're going to double distribute this out. All right, so let's distribute 5 first. That's 5 minus 15i. We'll distribute the negative 2i. That's negative 2i plus 6i squared. Negative 2i times negative 3i is positive 6i squared. Okay, on the bottom. Remember, with conjugates, you only have to multiply the first terms together and the last terms together, because the middle terms are always going to end up canceling out. Okay, so let's do that. 1 times 1 is 1. 3i times negative 3i is minus 9i squared. Okay, now we just got to simplify this down. All right, so on top, 15, I can combine like terms. That's a minus 17i. Plus 6i squared is going to change to minus 6. I'm going to combine the 5 and the negative 6 together in just a second, but I'll finish the bottom also. Okay, so negative 9i squared is going to really change to plus 9. 1 plus 9 can be added together to get 10 on the bottom. All right, let's finish the top. 5 minus 6, I'm going to combine those together. That's negative 1 minus 17i all over 10. Okay, again, there's 3 numbers here, and I want to check to see, is there a number that goes into all 3 of those? There isn't, so that's simplified all the way.